Hello and welcome. Today we'll be discussing the elements of plane geometry. So our focus is on plane geometry, that's geometry of plane shapes. So we'll be dealing with lines and then plane figures like triangles, that's trigonometry, and the circle geometry, that means about circles. But for now, we'll start from the very simple ones, that is straight lines. This particular section of the video will focus on the introduction of the elements or the theories that we are going to use in solving problems. This class is very essential and very important for students preparing for JAMB exams or UTME exams, WAEC exams, GCE, nursing schools, and other similar exams. You can send us your questions if you have any for this class. You can send it through our email, which you will see on the screen. Forward your questions, and if there is any other topic you would like us to treat, also send it to our email. Then you can equally join our online community learning group for more questions and insights. This class is totally and completely free. Okay, so let's start. In plane geometry, or in geometry, which is the study of lines and angles, we'll first of all have to understand the basic and the fundamental principles that will guide us through the lesson. So, what are those basic principles? One is about angles. An angle is formed when two lines meet. They will form an angle. So we have various popular angles like angle at a point, which is also called angle in a circle. So a circle is a complete figure. So when we have angle in a circle, or angle that we also call angle at a point, we give it a value of 360 degrees. So angle at a point or angle in a circle has the value of 360 degrees. These are the things we will have to know, that angle in a circle is 360 degrees. Then again, we will now know that if angle in a circle is 360 degrees, if we can slice the circle. When we slice the circle, you can see that what we use to slice the circle is a straight line. And then by slicing the circle, we have divided the circle into two equal parts. And so we have angle on a straight line. So a straight line slices the circle into two equal parts. So we now have angle on top and angle below. So either of them, any angle on a straight line is given the value of 180 degrees. So angle on a straight line is 180 degrees. And that is another important angle. So we can go ahead and still slice this into two equal parts again. Then we'll have an angle that is very, very important. And this time around, we have divided our circle into four parts or four quadrants. So you now see that we have a vertical line, a horizontal line, and then a vertical line, and then an angle is formed there. So this angle, each of these angles, this angle, you can see that I'm giving it a special symbol. It's no longer a curve because it is a very important angle, and this angle is called a right angle. Anywhere it is located, it is a special angle formed between a vertical line and a horizontal line. So that is right angle, which is always called given the value of 90 degrees. That is 180 divided by 2, which is 90 degrees. So this is angle 90 degrees. This is angle 90 degrees. If I put it here again, that's angle 90 degrees. Even here again, we still have angle 90 degrees. So it's when you add four of these angle 90 degrees. So 90 plus 90 is 180, plus 90 is 270, plus 90 is 360, which will return us back to a circle. So when we get angle in a circle and divide it into four equal parts, we will now have angle 90 degrees. That's right angles. These right angles, remember, It can be anywhere. Like we said, angle on a straight line. The straight line can be inclined. This is still a straight line, and angle on a straight line is 90 degrees. Anywhere you see the straight line, no matter how the straight line is, it is 180 degrees. Now, if you slice it into two, you still get your 90 degrees, no matter the inclination. So even if the straight lines are not vertical and horizontal, even if they are inclined angles, inclined lines, but the angle between them is 90 degrees, that angle is called a right angle and is represented by a symbol of sharp lines, angle 90 degrees. So anywhere you see this symbol, you already know that it's angle 90 degrees. Now, still talking about two lines that cross each other. What if those two lines did not make right angles? Like we have said, we have discussed situations where the two lines will form angle 90 degrees, as we just saw. But then, what if the two lines cross each other and they did not form angle 90 degrees between them? Situations like that usually occur, and then we'll have maybe two lines as such that did not form angle 90 degrees, but they will form other angles which we don't know their values. So an angle can be formed here, 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 and here. These are various angles, 4 angles that they formed. Now, but from our basic geometry, we know that if I call this angle A, and this is B, C, and the D, then I can probably say that angle A is equal to angle C, and angle B is equal to angle D. What is the reason for that? Angle A is equal to angle B and C equal to D because they are called vertically opposite angles. Vertically opposite angles. These have been found to be true for any set of lines in measure. So angle A and angle C are equal, they are vertically opposite. Angle B and angle D are equal. We have to keep note of this and always keep it in our mind because we always use this and the other similar theories. Okay, now one other thing you can see from this our diagram is that angle A and angle D will give you 180 degrees because they are angles on a straight line. You can see that this is a straight line. So A and D will give you, A plus D will give you 180 degrees. Also, A plus B will give you 180 degrees. And then B plus C will give you 180 degrees. Then C plus D will equally give you 180 degrees. They are all, you can see the straight line here. So this is B and C, and so on and so forth. We can actually prove that A is equal to C and B is equal to D, but because of want of time, let's just leave it at that. Okay, so then we'll talk about a very important concept on parallel lines. So we'll talk about parallel lines. So what we are seeing right now are two sets of lines that can be described as parallel lines. What do we mean by parallel lines? When we say that two lines are parallel, what we mean is that if we extend those two lines to infinity, to no end, like an endless point, those two lines can never meet. So if we continue to extend these two lines, it is not possible for them to meet. So this and the parallel lines are represented with arrows. They are designed with arrows. So when you see arrows on any set of lines, you know that it is indicating that those two lines are parallel. It can be 3 or more. What we know is that once you see any set of lines with the same number of arrows, it means that those lines are parallel. Now, the arrows might be single or multiple arrows. It can be 1, it can be 2, it can be 3, but they will have the same number of arrows to show that they are parallel lines. Now, let me cut these lines with a single line, which I will call a transversal. So I will transverse these lines, and then when you see that, you can see that once I transverse them, you will see angles being formed on them. I will have an angle is formed here, 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 and here. Similarly, angles are formed here, here, and here. Now you can see that the angles formed here, some of them corresponds to the angles that are formed here. So if I call this guy angle A, and this is B, this is C, this is D, for instance, I can call this guy A prime, I can call this B prime, C prime, and then D prime. Then angle A and A prime, A is equal to A prime, B is equal to B prime, C is equal to C prime, and the D is equal to D prime. What is the reason? They are all corresponding angles. Corresponding angles. You can see it is obvious that they correspond. Like angle A, the position of angle A will be equal to is exactly corresponds to the position of angle A prime. Position of angle B corresponds to the position of angle B prime. Position of angle C corresponds to that of C prime, also D to D prime. So they are corresponding angles. Also, taking from what we have learned before, you can see that A will be equal to C prime. A equal to C because they are vertically opposite angles, just like we mentioned. A is equal to C. Also, B is equal to D because they are vertically opposite angles. Now, you can see also, since A is equal to C and this A is equal to this A here, also this A prime is equal to C prime. It means that this A is equal to this C prime. Right? So A is equal to C and this A is equal to C prime. Because this A is equal to this guy and this guy is equal to this guy. So it means that this A is equal to this C prime. So I can say that A is equal to C prime. Also, in a similar way, B is equal to this B prime and this B prime is equal to this D prime. So I can say that B is equal to D prime. I can also say that C is equal to this A prime because C is equal to this C and this guy is equal to D. So I can say that C is equal to C prime. And then it's equal to A prime. Sorry, it's equal to A prime. So angle C is equal to A prime. Also, angle D will be equal to who again? D is equal to this guy, this D prime, and D prime is equal to B prime. So I can say that D is equal to D is equal to B prime. So angle A is C prime, B is D prime, C is A prime, and then D is B prime. These angles are called alternate angles. You can see how they are formed. Alternate angles. They are alternate. They are alternating angles. Now, you can see how they are formed. A corresponds to A prime, which is vertically opposite to C prime. So I'm saying that A is equal to C prime. C prime is the vertically opposite angle to A prime, which is the corresponding angle to A. So that's how you can always identify alternate angles. You see, you find this guy, you find its corresponding angle, and then the angle that is vertically opposite to it is the alternate angle. So that's how you identify alternate angles. This is about the theories that we need to prepare and answer all questions on plane geometry. Trust me, with these very few theorems, any question you get on plane geometry, you will finish it off with ease. Trust me, we are going to solve a whole lot of problems from JAM past question papers, from WAEC past question papers, and even the questions that you have been finding very difficult, your tough questions, you send them, we'll solve them here. Finally, before we proceed to solve problems, let us recall some of the basic theories we know about triangles. First is that we need to recall that the sum of angles in a triangle is 180 degrees. So we have that this here we have angle A, B, and C. So we can say that A plus B plus C is 180 degrees. That's sum of angles in a triangle. So we need to recall that. Again, we'll remember the triangle we call isosceles triangle. When it has two equal sides, we describe it as an isosceles triangle. So, and the one property of isosceles triangle is that if two sides are equal, it will imply that two of the angles will be equal. And those angles are the base angles of the isosceles triangle. So, base angles of isosceles triangles are always equal. So we can say that A is equal to B for this particular triangle because it's isosceles. You can see that the lines here indicate that this marks here indicates that this line and this line are equal. So, and since they are equal, then you can see that A is equal to B because these are the base angles of the isosceles triangle. So, which means someone can equally say for this triangle that angle A plus C is equal to 180 degrees. That means 2A plus C is equal to 180 degrees. That's for this particular triangle, which is isosceles. And then, lastly, for this one, we remember there's what we call a stereo angle of a triangle. The stereo angle of a triangle. You can see this triangle having angles A, B, and C. These angles A, B, and C are the interior because they are located inside the triangle. They are the interior angles. While angle D is located outside the triangle. Angle D is formed by extending one of the sides of this triangle. So then, by theorem, which we'll prove later, we will have that angle A plus angle B is equal to angle D. So angle A plus B is D. So we can say that A plus B is equal to D. The exterior, some of the rule we are obeying here is what the rule that says that the exterior angle of the triangle is equal to sum of the two opposite interior angles. So these two guys are the two opposite interior angles. So angle D is equal to the sum of these two guys. So in any of these triangles, if I extend any of them, if I can extend this guy and form an exterior angle here, let's call this guy B again. I can easily say that B plus C is equal to D because B and C are the opposite interior angles to this exterior. So these are the basic rules that we need to know to be able to solve problems on line geometry. So once we know these rules and keep them to our mind, then we'll be able to solve multiple problems on line geometry. So let's learn these rules, record them, and then in the next video we'll solve practical exam problems on line geometry.